In this video, we're going to take a look at the derivative and the tangent line problem. In particular, we're going to take a look at lines. We're going to look back at some algebra and look at secant lines. So as we look at a secant line to a curve, this is simply a line that passes through 2 points on that curve. Okay? So let's take a look at 2 points. So we have a point here and a point here. We will call this first point X. Right? We're going to draw a line between those 2 points. The first point is X, and the function value is f of X. And our second point, we can call that X2, and its function value is f of X2. And so we have the equation of the line between those 2 points. That line between the 2 points is shown there. That's the secant line. That's the slope of that is the change in y over the change in x. Beautiful. Now, for those 2 points, instead of thinking about x1 and x2, we can think about x and then a little bit of space, x plus delta x, a distance of delta x away from the first. We can think about the secant line between those 2 points. So if we have our first point x, and we have its function value right here, so that's f of x right there. And we have a step of delta x away, right? So we have x plus delta x, and then the function value there is f of x plus delta x. Right, just like this. And I accidentally wrote a subscript of 1. We don't need that. So we have x and x plus delta x as our 2 points. And so we can draw the line between those 2 points. And we have our secant line. So we have our secant line. This secant line has slope, change in y over change in x, f of x plus delta x minus f of x over x plus delta x minus x. So that is our secant line. Right there, those are the 2 y values. Those are the 2 x values. We can think about the equation of that line. Now, we're going to think about what happens as our value delta x, the distance between the 2 x values, what happens as that distance heads towards 0. Right? So as we think about that distance heading towards 0, this point right here, the second point, it is going to move closer and closer to the first point. It's moving along that line and closer to that initial point. It is delta x units away, and that value is heading towards 0, the distance between the 2 points. The 2 x values is heading towards 0, and so then the points are also getting closer and closer to each other. Right? And so instead of having the slope between 2 lines, between 2 points, we ultimately end up with the slope at a single point as that value of delta x goes to 0. So that's what we have for a tangent line. So a tangent line at some point here, let's say at x. A tangent line, we think of it as hitting the function at a single point. And so we draw this line that intersects at a single point. The distance between that and the next point is 0. And so we have these lines that are getting closer and closer to the slope at a point. So those secant lines have slopes that are getting closer and closer to a slope at a point. And we have this as our tangent line. So that's the idea of a tangent line. The tangent line is hitting at a single point. Now, in theory, it could hit at other points, either below or above the function. But locally, it's hitting at only a single point within some neighborhood. Fantastic. In our next video, we're going to take a look at what is the slope of these tangent lines and secant lines. All right, we will see you there.